All right, so this is 1.3 part 2. So we're going to be sketching piecewise functions. So we're going to be graphing, our favorite. We're graphing piecewise functions, so pieces of graphs. So yesterday we kind of talked about parent functions of graphs and the shape of graphs, so what they look like. So that is helpful to keep in mind when we are graphing piecewise functions as well. If something is just as an x to the first power, what do you think the shape of our graph is going to be? Yesterday we said x squared was a parabola, but what if it's just an x? A line. Perfect. So in 55, both of these are going to be lines. So it helps to know that so you know what shape of graph you're dealing with. Now when we graph piecewise functions, there's a couple things that we want to keep in mind to start. If we have a less than or greater than, then it would be an open circle. If we have a less than or equal to or greater than or equal to, we put a closed circle at that point. And then we always want to start with the values that are given. And I'm going to do one piece at a time. So I'm going to focus on the first piece here. So just the 2x plus 3. So the first thing I'm going to do is plug in the number that's given. So it says x is less than 0. So I'm going to start by plugging in 0. I'm going to do this so I can get points on my graph. So I have 2. I'm plugging in 0 plus 3. 2 times 0 would be 0. 0 plus 3 is 3. So my first point is going to be 0, 3. At that point, does it get an open or closed circle? Open. It is a less than sign, so we put an open circle at that point. So I'm going to go to my graph. I'm going to stay at 0, go up 3, and put an open circle there. Next, we want to plug in a point that gives us direction of our line. We know that it's going to be a line, so we really only need 2 points to draw a line. But we need to know in which direction we're going to go. So I can plug in anything that is less than 0. I want to plug in something that satisfies the inequality here. So what could I plug in for x that is less than 0? Sure, -1. That works. You could say plug in -2, -3, whatever you want, but -1 is a great choice. So we have 2 times -1 would be -2, plus 3 would be what? 1. Awesome. So we plugged in -1 and got 1. So I'm going to go to my graph. I'm going to go to the left to -1 and up 1. Now this second point just tells us direction. It is not a defined open or closed circle. It's just where our graph is going. So the second point that we plug in is just the direction. The only one that gets a defined open or closed circle is the 2 that are here. The rest of them just show direction. So I'm going to start at my open circle there, and I'm going to go through our other point and draw a line. So this is our first piece of the graph. Any questions on how we got that? Next, let's move on to our second piece. So I have 3 minus x when x is greater than or equal to 0. So first, I always want to plug in the number that's given. So I'm going to plug in 0. So we have 3 minus 0, which would be 3. So I plugged in 0 and got 3. At this point, is it an open or closed circle? Closed, because it is a greater than or equal to sign, so it's a closed circle here. So I'm going to go to my graph, stay at 0, go up 3, and put a closed circle. It's okay if those points overlap. One of them was an open circle, so it wasn't including 3. The other one is a closed circle, so it's okay if they overlap. Next, Let's plug in something that satisfies our inequality. So what can we plug in for x that is greater than 0? Sure, let's plug in 1. So we have 3 minus 1, which would be 2. So the next point I'm going to have that gives us direction is going to be 1, 2. I plugged in 1 for x and got 2 for my y. So I'm going to go to my graph, go to the right one and up 2. If you want to plug in more points, that's totally fine. But with a line, you only need 2. So I'm going to connect the pink dot and the red one, and that is going to give me the direction for my second piece. Awesome. We're going to skip 57. We'll come back to it, but let's do 59. All right, so with 59, we're going to do one piece at a time. So I'm going to start with the first one. What number am I going to plug in first? 0. We always want to start with what's given. What's the shape of this part of the graph? Yes, it is a line. It's in the form of y equals mx plus b, so it's linear. It's going to be a line. So let's start by plugging in 0. We have 0 plus 3 would be 3. So my first point, I plugged in 0 for x and got 3 for y. So 0, 3. Is this going to be an open or closed circle? Closed circle because it's less than or equal to. So I stay at 0. I'm going to go up 3 and put a closed circle. Next, we need to know which direction our line's going to go. So I can plug in any other point that satisfies my inequality here. What's a number that is less than 0? -1, sure. You could plug in -2, -3, anything less than 0. So we're going to plug in -1. -1 plus 3 is 2. So I plugged in -1 into x and got 2 for my y. Now remember, the second piece just shows us direction. So it's not a defined open or closed circle. It's just which way our line is going. So go to the left to -1 and up 2. My graph is going to go this way. So you start at the number that you started with, that point, and you go through the second point. Which makes sense because we're talking about x values that are less than 0. So since we're less than 0, we're going to go to the left of 0. Talking about x values left of 0. Let's go to our second piece. What shape is the second piece going to have? What is just a constant number? Not a vertical line. It'll be horizontal. Yes, it's going to be a flat line, a horizontal line. So we want to plug in the two numbers that are given here. So since this has a middle piece, whenever your piecewise function has 3 pieces, the middle one's going to have 2 numbers. So we're going to plug in these 2. So I'm going to start by plugging in 0. I don't really have anywhere to plug in 0. What's my y going to be if I plug in 0? What's our y? 3. 3. This is our y. So if we hypothetically plug in 0, we're going to get 3. Is this an open or closed circle? So at 0, it's going to be open because it's just a less than sign at 0. So I'm going to go to my graph. I stay at 0, go up 3, put an open circle. Here they happen to overlap too. It's not going to be the case every time that they overlap. Just so happens in these examples. Next, we want to plug in 2. 2 is the second number in this piece. If I plug in 2, what's my y? 3. The y is always 3 because we're not plugging in anything here. Our y is just 3. So if I plugged in 2, I get 3. Is this an open or closed circle? Closed, because at 2, it is a less than or equal to sign. So we have a closed circle. So we're going to go to the right 2, up 3. and connect our 2 points. We don't need more points to plug in here because we know that it's just going to be a constant line. It'll be horizontal. Now this one does not get an arrow because it has a starting and a stopping point. We're only talking about the x values from 0 to 2. So the x values of my graph, this graph is just going to go from 0 to 2, this piece. Any questions so far? All right, let's do the third piece. What shape will our graph have here? It's going to be a line. This one's also going to be linear. What would we plug in first here? 2. Always plug in the number that it gives you first. So we have 2 times 2 minus 1. 2 times 2 would be 4. Minus 1 is 3. So we plugged in 2 and got 3. Do we have an open or closed circle here? An open circle. So I'm going to go to the right 2, up 3. We have an open circle there. Again, it's not going to be the case all the time that they overlap. It just so happens here. What should we plug in next? What should we plug in to give us direction? Sure, anything that is greater than 2. So let's plug in 3. So we have 2 times 3 minus 1. 2 times 3 would be 6. Minus 1 is 5. So we plugged in 3 and got 5. So our point's 3, 5. Now remember, this point just gives us direction. So it's not a defined open or closed circle. It just tells us which way we're going. So I'm going to go to the right 3 and up 5. And then we can connect our dots. We start at the first one and we go through the second. Which makes sense because we're talking about x values that are greater than 2. So our graph is going to the right of 2. And this would be our graph. Any questions here? With your piecewise functions, they are functions. Keep that in mind that these are going to be functions. Remember yesterday when we talked about the vertical line test and we said what's a function, what's not a function? These are going to pass the vertical line test. If you end up with a graph that had one piece that was going this way and another piece that was going this way, you did something wrong because this does not pass the vertical line test. If I put a vertical line on my graph here, it touches at 2 points. So all of these are going to pass the vertical line test. That's one way you can check your work to see if you did something wrong. If your lines are going the same direction, you probably did something wrong. All right, so with 57, we kind of talked about square root graphs yesterday. Does anybody know what shape a square root graph has? It's kind of got the shape of a square root. It looks like this. Now this could change if we have a reflection, if it shifts, if we have some transformations happening to it. It might go the other way. It might get flipped upside down. But it's good to keep in mind that we've got a shape like this. It's not linear, so we may have to plug in more than one number. We don't have any examples here, but if you had, let's say, an x squared graph. So I'm going to take a pause from 57. But let's say we had an x squared graph. What's the shape of an x squared graph? A U, a parabola. Now, when we graph our parabola in a piecewise function, if we're just talking about a piece of our parabola, we could have the piece that goes here. Let me use a highlighter. We could have this piece here, where it's got that U shape. We could have this piece here, where it's almost linear if it just went like this part of the graph. So with parabolas, you definitely want to plug in more than one number so you know which piece of your parabola you're talking about. So with parabolas, I would say plug in at least 3 numbers. With lines, you really only need 2. You need your starting point and you need the direction. With x squared graphs, you want at least 3. That way you know which piece of the parabola that you're talking about. All right, let's go back to 57. So with 57, starting with our first piece, what do we want to plug in first? 0. Awesome. Always start with the numbers that are given. So I have the square root of 4 plus 0, which would be the square root of 4, which is what? 2. So what would our first point be? 0, 2. We plugged in 0 for x and got 2 for y. So 0, 2, is this an open or closed circle? Open circle. So I'm going to stay at 0 and go up 2, put an open circle. Now this one we got to think a little bit. Dominic. We can plug in -3. That totally works. That's a great number to choose. Why did you choose -3? Awesome, because we know it's going to give us a perfect square. And it'll give us a nice whole number. So when we plug in -3, that satisfies, that is less than 0. So we're going in the right direction. So it has to satisfy our inequality here. 4 minus 3 would be 1, and the square root of 1 is 1. So what would our point be here? -3, 1. Perfect. So I'm going to go to the left 3 and up 1. Now this isn't just a line, and it doesn't go in the same direction forever, depending on which part of our graph that we're talking about. So we may want to plug in more numbers. What else could we plug in here? -4, perfect. Let's plug in -4. So 4 minus 4 would be 0. Square root of 0 is 0. So -4, 0. Now again, this just gives us direction. It's not a defined open or closed circle. So go to the left, -4, stay at 0. So this is good. We're starting to have that square root graph shape. Now can I plug in -5? Will my graph have this type of arrow? Does it keep going forever? Why not? Why can I not plug in -5? You can't have a negative under the radical. So the smallest number that we could plug in is -4. Our graph is going to stop at this point. Because 4 minus 5 would be -1, and this is not a real number. Anything smaller than -4 would not be a real number. So our graph stops here. So we go from here to here. So this would be our first piece of the graph. Any questions on the first piece? We're okay so far? Let's do our second piece now. What are we going to plug in first? Awesome. We want to plug in 0. We want to plug in the number, bless you, that it gives us. So we have 4 minus 0. What's the square root of 4? 2. So what would our point be? 0, 2. Is this an open or closed circle? Closed circle. So I'm going to stay at 0, go up 2, put a closed circle. What would we plug in next? Three, great choice. We can plug in anything greater than 0. 3 is a great choice because we know it's going to give us a whole number. So we have 4 minus 3, which would be 1. Square root of 1 is 1. So we plugged in 3 and got 1. So we're going to go the right 3 and up 1. What can we plug in next? Let's plug in 4. 4 minus 4 would be 0. Square root of 0 is 0. So we plugged in 4 and got 0. So I'm going to go to the right 4, stay at 0. Can I plug in anything greater than 4? No. Why not? It would be negative, and we can't have a negative under the square root. So we know that our graph is not going to have an arrow. It's not going to go forever this way because we can't have x values that are greater than 4. It's going to stop at 4. So our graph is going to look like this. So this would be our piecewise graph for 57. So you have to be careful when you have square roots. You got to keep in mind, can't have negatives under the square root. When you don't have square roots, when it's just a linear graph or a constant or an x squared, it's just basic graphing. Plug in numbers, plug in x's, get your y's, plot your points. Any questions?